Good morning. I am Reggie, Associate Professor, Department of ECE. Today we are going to discuss about 5G concepts and challenge. 5G deployment architecture. On completion, students will be able to understand the basics of 5G deployment architectures. 4G consists of two significant architectural components, LTE for access network and evolved packet for core network. However, 4G access and control component cannot interwork with other legacy network component belonging to previous generation wireless network. However, 5G provides interoperability with 4G network. 5G architecture support both standalone architecture and non-standalone architecture. Non-standalone architecture implementation allow 5G network to interwork with 4G network. The standalone architecture is an end-to-end 5G network. The initial deployment of 5G will adopt non-standalone architecture. So the figure shows that standalone architecture, standalone LTE with EPC, standalone NR with 5GC, and option standalone LTE with 5G core, standalone deployment architecture. Standalone architecture uses only one radio access technology with either 4G or 5G. The radios will connect to either 4G EPC or 5G core. Architecturally deployment standalone solution is simple for service provider, but involve lot of cost. End-to-end 5G network has been deployed. When a user equipment switches from 5G and 4G network, service continuity is achieved through intergeneration handover. Standalone architecture has three deployment, option 1, option 2, option 5. Wireless service is provided by 4G LTE Node B and 4G EPC. The deployment option is supported by the existing 4G network. It supports higher bandwidth of 400 Mbps and is adequate for mobile broadband. Wireless service is provided by 5G NR, G Node B and 5G core. This is full end-to-end 5G service and it will take few years for network to adopt deployment model. But option 5, wireless service is provided enhanced 4G LTE Node B and G Node which communicate with 5G core. The deployment option is helpful for service provider during migration of full 4G network to 5G network. Non-standalone architecture.
Rupees 300 received on PhonePe.
With a non-standalone mode of deployment. In non-standalone 5G will support existing 4G technology. This is the non-standalone deployment option. It is having non-standalone also will have three options. Option 3, LTE E node B act as a master node and 5G NRG node B act as a secondary node. Both the RAN function connect to 4G EPC. Option 3 deployment will be helpful in scenario where the UE can connect to large 4G cell towards internet service and connect to the 5G cell for high data throughput. Option 4, 5G NR act as a master node and 4G LTE act as a secondary node. Both the RAN function connect to 5G core. Option 4 will help in scenario where 5G coverage is high and with the areas is not available. This deployment option may be relevant in short term where 4G coverage is higher than 5G. Option 7, 4G LTE act as a master node and 5G act as a secondary node. Both the RAN function communicated with 5G RAN core. Option 7 built on the top. The need of option 7 is limited in short term and its benefit to mobile broadband use cases. So from this topic, students can understand what is SA stands for. Standard access, standalone architecture, service authentication, satellite organization. In the non-standalone 5G deployment, which network is primarily control the signal? 5G NR, Wi-Fi, 4G LTE, satellite. Which component in 5G handle the user print data for AMF, UPS, SMS and UEF? Thank you.